All right. Testing, 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 testing. Mic check, one, two, three. Mic check, one, two, three. All right, we're in it. All right. Well, welcome everyone to Deep Station. Thank you all so much for coming on a wonderful Friday. Let's give a round of applause for everyone here coming on a Friday, looking to learn more about AI. Who here is looking to learn more about vibe coding on an enterprise scale and MCP servers tonight? Look at all that. All the hands up in the room. Well, thank all of you again so much for coming. Today we have two special guests, Dustin Gallegos and Muntazir Syed, and we're going to be talking a lot about enterprise vibe coding as well as MCP server best practices. And we want to share with you a bit about Deep Station. So what is Deep Station, right? Deep Station is a community where we bring people together, developers, engineers, professionals, so that we can all stay ahead of the AI wave. Everything is moving so fast, as we can all tell. I feel like every day a new model is out, a new app is out, a new MCP server is out. It just feels like everything is changing so fast. Coding assistants are now all the rage, and by having a community like this, we could all learn and grow together. So thank all of you again, one more time for coming. And we wouldn't be able to do this without our wonderful sponsors. Let's give it up real quick for the lab and the doc for giving us this wonderful venue today. Thank you so much. Thank you so much. We also want to give thanks to our other sponsors, Miami TechWorks. Miami TechWorks is helping to accelerate, basically helping to bring together the community here so that we can help people get jobs, help them get resources, help people start their career in tech. And they are funded by the Department of Commerce and the United States EDA. And they are a proud sponsor of Deep Station. And so thank you again so much for Miami TechWorks. If you're looking to stay engaged with the tech ecosystem here, feel free to join their Miami TechWorks Talent Coalition. They're really great at helping people get jobs, and we're proud to be a proud supporter of that. So if you're looking for a job, you need help, feel free to reach out to us and we'll get you connected. Thank you. We'd also like to bring and give thanks to Kaufman Rawson, the leading CPA advisory firm here in South Florida, the 50th largest in the United States as well. If you're a startup, you need help with basically getting investments, or you're having a Series A or Series B and you need support during all of that process, they're the accountants that can help you. And of course, if any of you need any type of applications, AI agents, or anything of the sort, Deep Station actually also has a consulting wing where we will build those solutions for you. So if you need any support building out AI agents, MCP servers, feel free to let us know, and we're more than happy to help with our really incredible AI engineering team. So if any of you haven't joined our WhatsApp group, or LinkedIn, or Instagram, or X, or YouTube, feel free to scan this QR code right here. You can go ahead and join our community. Thank you so much for putting up those phones. I really appreciate it. The LinkedIn really does help us out, get us more engagement, and our WhatsApp group allows you to stay directly connected to all of us right here in one WhatsApp group. I think right now we have 650 people in there, mostly in the South Florida area, 500 in Deep Station India chapter. And so we're definitely accelerating very quickly. And that makes all of this possible. And if you are looking for the Wi-Fi password, which I'm sure some of you are, here it is right here, the Lab Miami guest. Thank you again. And I want to give one more special thanks also to our other sponsor, Miami-Dade College. Let's give it up to Miami-Dade College. Amazing, amazing. Yeah, they are really changing the economic landscape and providing so much accessible AI education. So if any of you are looking for a degree, or you're looking for education, just head on over to Miami-Dade College. You can get an applied AI degree, as well as going to the AI clinics, where they offer a great course if you're looking to get more into AI. So without further ado, we're really excited to bring up Dustin Gallegos, my good friend. Thank you so much for coming. You know, we've been knowing each other for what, over a year now, is that right? Yeah, the last time you came, you know, it was one of our best events yet. And so thank you so much for making that happen. And so what will you be talking about today, Dustin?
Yeah, I'll be talking about how to use vibe coding, but in a different way, in a more reliable and enterprise-grade level.
Amazing. Well, we're very excited for that. So you're now with you're the founder and CEO of K-Million, AI consultancy, and also you're formerly at Microsoft. Is that right? As a solutions architect, and amazing. Yeah. So if you're looking to get advice about how to build big systems and make them production grade, Dustin is definitely the person to talk to. So without further ado, take it away.
Well, thank you so much, Grant. First of all, thank you, everyone, for making it on a Friday afternoon or night. I know it's not perhaps what you expected to do at the beginning of the week, but here you are learning. And I think this is very important. What, like Grant said, the world is changing so much, so fast, and every city is moving so fast around the world, and everyone's making an effort to stay up to speed. And if not, then yeah, it might not go so well. So thank you for making the effort. Thank you also for everyone that has sponsored this event. It's something really important that really promotes the city, really brings everyone together, and gets everyone learning. So with that, I wanted to, well, give an intro to my conversation. So I'm here to really just wanted to set the expectations here. I'm not here to show you extensive lines of code. I'm not here to show you like extensive or really tricky technical tricks and things like that. Even though that's something that I really love to do. That's what I studied for, and that's what I worked every day with. But I'm here to explain to you more of a change of mindset on how to build with AI. And so the expectation is that after this conversation, hopefully you will come home, or you probably do it right now, and start thinking about how to build with AI in a different paradigm. So here we go. Please, by the way, this is also a moment for me to learn, because I've tried different things. I saw out there what was working and what was not working. And then I decided to just try myself something different. So I'm sure that this is going to continue evolving. And some of you might have done things differently, maybe better. And so I would love to hear, as I'm progressing to the talk, please raise your hand and let me know if you did it differently. I would love to learn too. So this is a moment for everyone to learn. All right, so who we are? Well, yep, Grant mentioned it. We're an AI team that have been building solutions since 2017. We're based in Miami, but we're also now present in Barcelona and in South America. And so we're pretty proud of our record, and also of bringing a lot of knowledge and a lot of solutions to different companies. So let me just begin of how this sort of journey started for me. So to begin with, I am more of a traditional engineer. I worked in Microsoft for 10 years, and so we built solutions enterprise level in a very sort of rigid way, in a sense. Of course, very safe, and also in another sense, right? So I come from this sort of more rigid mindset. And so when we built our consulting team, we serve enterprise companies, so we had to also apply the same methodology so that we deliver very solid solutions. So this is sort of where I was. And so I was kind of skeptical about building with AI, even though we used AI and delivered it to other companies. We were kind of skeptical to use it at an enterprise level. So this is to begin with. This is how my journey began. And then I had an idea that came up to me actually around this time last year. And then I was like, well, what if we try this idea with vibe coding? But then I was like, okay, well, I started thinking about it, researching more and more, and really the reality is that these days, what I saw out there, what people normally teach you is that the promise of vibe coding is something that is going to be fast, and it's going to be, you can build rapid prototypes, which is true, all that is true, and it's really fast. But the reality is that sometimes it really lacks the solidity of a good architecture, also the good practices that need to be behind some end-level code. Because maybe you can put together something fast, but then later on you're going to have to come back and redo it. So anyway, there were some limitations that were sort of red flags before we started. And so I had this idea to build this solution at the beginning of last year, but our team was pretty constrained with resources, so we really needed to put something together fast, but we couldn't take them shortcuts. So I decided to myself start learning or creating my own sort of methodology or my own way of doing it. And that's how I got myself involved. I took a month off, and then I decided to just start building and going at it, like for a month straight. And so this is where everything begins. And so to begin with, the concept of what we normally aspire when we build with AI is like, I want to just build it fast. Let me just build it, do it fast, which is great. For prototypes, is great. But once you really go serious about it and you have a solid idea, you have some backing, whatever, you really need to think about doing it right. So, so that's sort of, let's begin with that thinking. And then so I decided to kind of put this, start pulling together my own sort of way of doing it. And the sort of ultimate vision of what this looks like is more or less like this, right? So what it is basically, the concept is that you have an architect at the center of it. And what does this architect do? Basically, the architect is that channel between your ideas, your concept, your designs, and the technical part, right? And the technical part, your technical crews, are these other components, right? It could be a front-end AI that we'll talk about. It'll be a back-end AI, depending, of course, of how many components your solution has. Also, our solution, the one that I put together, has also a client on a Mac OS and a Windows component. So it's an Electron app, basically. So also a QA AI that helps you put a test and making sure that whatever you built is right. And then some documentation AI. So putting together all these components and sort of orchestrated one sort of brain is actually a more powerful AI with more memory, with more capacity, and more expensive, of course, but that is going to really be that bridge between you and all the execution. Up to here, anyone has done something like this? Feel free to comment, or yes, go ahead.
We're building something similar, the fact that we're doing that in the form of a story. So the idea is that you take the workflow with a problem and you break it into the story format, and then you take that same story, that object, through these different agents.
Yeah. Okay. Great. Awesome. So it's more like a story. Does it have to do with features or okay?
Yeah, so it's standardizing on the UI experience.
Perfect. Okay. Perfect. Okay. Great. So it's more around user experience, I hear, right? Or is it more UI based?
It's a longer conversation.
Okay. Great. Okay. So the reason why I asked that is because one of the things that I learned as I was putting this together is that you don't just do a huge prompt and you just go and then you expect the AI to know everything. One tip that I can give you, if you're thinking about an idea and you're somebody that is perhaps a little bit technical, and then you're thinking, okay, well, I know more or less how this should be built, then it's a good idea to take that idea and start breaking it into parts. Start working from the top to the bottom. The bottom meaning like the smallest features or functionalities. So you start with, perhaps you start with the foundations of what you're trying to build, and then work your way around. You work your way down onto the smallest details. So let me show you sort of some examples of what this means, like what these components kind of do and how do they look like, right? And so what you can do, and what I've done as well, is to put together basically is an AI on ChatGPT that is basically a project that I feed with a very refined prompt, and I feed with a bunch of files, right? And the files have to do with the solution, what I'm trying to do. So I feed it as much information as I can, of course, useful information, and then I have this AI as sort of my architect. You can do the same thing with Claude. You can do the same thing with other AIs. I would say is more or less you get similar results. The important thing is that you dedicate one AI and you specialize. You can do it with Copilot, by the way. There are Copilot agents, Microsoft Copilot agents. And you basically, you feed it as much information as possible so that the AI has the context. But it's not just technical information. It's also a business information. It's also marketing information. It's also user experience. It's also, I mean, you have to really give it the full context so that it understands also where features come from. It's not just about building a button. It's not just about building a feature. It's really about the AI understanding the context of what you're trying to build. So this is what I put together. Anyone here uses ChatGPT projects? Anyone? Yeah, okay, a few people. Okay, great. Any other tools that you guys use that are similar to this? Copilot, maybe? Anyone uses Copilot? Yeah, okay, great. Okay, okay, so that was more or less our architect, right? And then this is our front-end AI. And so Lovable, anyone uses Lovable here? A few, okay, a few of them. Okay, great, great. So this is what we use as a front-end AI, and so we, of course, is a vibe coding tool, right? So we basically feed information, but in this case, the difference between just typing something is that we actually barely type here. What we do is we use the prompts that the architect is giving us. So the architect has a meta prompt that says, when we are ready, when I tell you, okay, we're ready to ship this idea into execution, then I want you to give me all the prompts for every one of the components that I showed you before. So for each one of these components, so whenever I'm ready, this AI architect is going to tell me the prompt for this guy, this guy, this guy, and all of them are going to also report back to the main architect to make sure that the execution was correct. No, each one of these are different vibe coding tools. Yes. Well, you can think of it also as a project itself. Yeah. I mean, with their own AI, with their own tools, with their own files, with their own everything. Yeah. Yeah, sure. So if I understood correctly, you're saying like, are each one of those just sub conversations of the main AI? Is that your question? Yep, yep. Yeah. Yeah.
Conversations with it and knows exactly what to do without filling the context window, yeah?
Yeah, yeah. So what it is basically the main architect AI chats with me, or I chat with it, and I say, hey, we're gonna now build X feature, and this feature is going to have X, Y, or Z. You know, I explain it, and then of course the main AI, the architect AI, knows about the rest of the components because every time a new component is built, it reports back to the main AI. And so the main AI is aware, it has MD files. You guys know what MD files are? So it has MD files that the architect AI is constantly reading to see what is the progress of what's being built. And so it's not exactly that it's within the same tool, but it's more like they are reporting to each other. They're connected to each other so that the main architect knows what's happening. Yeah. So yeah, you have a question? Yeah, sure.
So do those PDFs have like your requirements?
Yeah, exactly. Requirements, it has designs, it has branding, it has marketing, it has all sorts of information.
And the AI is going to tell you, like, for the front end, it's going to use Lovable, so it's going to tell you what product or solution to use for each of those.
No, not to use. It's going to tell me what prompts, what instructions the front end is going to need to build whatever feature that we're building next. It's going to tell me this is the prompt for Lovable, this is the prompt for Supabase, this is the prompt for. That is exactly, yeah, that's exactly the configuration. One thing that I would say, I didn't say this before, thank you for mentioning it. I actually spent probably 3 days, just 3 straight days, just setting up everything. Like, setting up the correct prompt for the architect AI, setting up connections between the different AI, setting up documentation, setting up, like, it took me a long time. Like, we didn't write one line of code for like half of a week. So it takes a long time to get set up. And then you can get started. Versus normally, what you do is you start building before you actually start thinking about it. So anyway, so let's move on. How are we doing with time? Yeah. Okay, yeah, let me know. All right, so this is the backend. This is the Supabase. Anyone who uses Supabase here? Okay, wow, a few people. Great. It's great, right? You guys like it? Yeah. Okay, so this is the backend assistant. This is backend. Well, some log. I mean, this is just a screenshot of what's happening in the backend. But this is our backend AI, right? So you can use others. If you like, you can use GitHub. This is our client-side, the client-side view. And in this case, I just took a screenshot of our QA agent that is built inside of GitHub Copilot. And this is to build an Electron-based application that is communicating with the backend. In the backend, there's SOPA-based, but there is also some specialized AI services that we need to use in real time to do what we did. So anyway, but this is just a screenshot of Copilot. And here in Copilot, we have this, right? You guys have used probably, let me see if I can show you. No, sorry. I thought I had another screenshot. But anyway, in Copilot, you have the option to select, of course, to chat with your agent and all that, but you also, within the agent, you have different sort of personas that you can invoke, right? You can invoke the planner agent, you can invoke the builder agent, the asker. You guys know this, right? Anyone, this is familiar to you guys, right? In Copilot, you can do that. You can do that also in, what is the other tool? Cursor, Surfer. Well, there are so many, right? Yeah, exactly. So you can do the same thing. So basically, once you are executing, you take the instructions that the main AI gave you, because it's giving you instructions every time you're executing it, and you take that instruction, or you can connect it as well. By the way, you can do a direct connection between Copilot or ChatGPT into these tools. So you provide that, and you continue to build in sort of parallel, right? And this is knowledge. Okay, yes, this is an example of Lovable knowledge. We fed a lot of information here to Lovable as well. And so this is the other part. We did a bunch of testing using DevOps test plans, it's called. And so we connected test plans to Copilot, GitHub Copilot, and we run some tests, automatic tests, using DevOps test plans. So anyone uses DevOps here? Nobody? Oh, one person. Okay, 2, 3. All right, great. Okay, great. So this is so basically this is what we just explained. It's basically we plan, or the mindset is first we plan for a feature, we work with the architect, we come up with the plan with the detailed instructions. Then those instructions are reviewed. I'm sorry, that plan is reviewed, and then it's built with those instructions, and then we review the output. Of course, if you're a technical person, you're going to review them, and you're going to verify that the output is what you needed. As well, you can have the AI architect review all the results. Make sure that you're all the time asking your AIs to document everything they do. Especially when you're done with some sort of feature, make sure you write MD files at the end of every execution. Yeah.
Yeah. So I'm not a coder. Oh, yeah. Thank you. Just the first few slides where you showed us the 4 or 5, the circular one.
Yeah.
Where you spent 3 days building them. Are these separate agents?
These are separate agents, yeah.
That communicate with each other?
They are communicating with, in our case, we set it up to communicate with each other. You can also just copy and paste information from one to the other. That's fine.
And the whole goal is for you to vibe code in a much better, more efficient, more accurate way, right?
Exactly, yeah.
Okay, got it. Thank you.
Yeah, that's the idea, yep. Yep. Oh, yeah.
So, back in the day, people used the model view controller.
Yeah.
And you can just buy a book just to learn that, or just get templates. But is there anything standardized, or does everyone have to reinvent the wheel? Every 3 days doing this, because it seems like everyone would have the same issue, right?
Oh yeah. That's what I saw online when I looked, because I just wanted to learn as well.
So maybe you should write the book.
Yeah, maybe we'll have an AI write the book.
Have the appendix with the source code.
Yeah, exactly. Yeah, but I don't know. I mean, again, this is what I've learned to work for us. Maybe you can try it yourself and see if it works. Maybe you can send me a message later on. I'm really curious to see what works for you guys or what not. Please, I'm here also to learn. So, yeah.
The way I was building it, I had a N8N MCP hooked up to Cursor, and so the big problem with AI is context storage.
Exactly, yeah.
I guess kind of my way of doing the architect AI was I created an agent contract sheet. So with N8N, you have nodes, right?
Yeah.
And so my kind of pre-planning or a PRD in a way was building out, it was like 1,500 lines of contracts between each node and the responsibilities between each node. And this way, when I'm, building out the project, I could always refer back to that agent contract. So I'm making sure I'm
Yeah, no,
staying
that's
on
awesome.
the line. Yeah.
Nice. Yeah, I like it. That might work very well too. Yeah. Do you have a comment? Yeah.
I just have a question on how they communicate to each other. So even when you want to run this on its own, like just one agent to do it all, right? And we can use Lovable or just through the IDE.
Yeah.
You fix something on the front end and it doesn't, even though it's all in one same spot, it doesn't necessarily update in the back end and it all being within one. So here, when you're now separating it, how does that knowledge transfer? If you're fixing something, you're doing an update on the front end piece.
Yeah.
How does it know to maybe now have another page to do QA, on? And, just curious as to how you get it to work so that they're all actually working in sync.
Yeah.
And maybe that's a 3-day kind of legwork.
Yeah. So basically, you can use NNN. You can use some sort of protocol that connects everything together to inform them of what they're doing. NNN is actually pretty nice, and you can spin up your own version and all that. You can use other ways of doing it. We did it with WebSockets, but you don't have to do it that way. But yeah, you can set up in different ways. But the one thing that I would say is very important. Is like make sure that your AIs are documenting everything they're doing, and also make sure that your prompts for each AI refers back to that documentation before they do anything. One of the instructions is going to say something like, before you start building anything, go back to your MD files, make sure that you read and understand what's the status of this feature right now. The same thing for the QA tester. The QA tester writes a report and tells everyone else what's happening, right? So anyway, let's move forward. What else I wanted to show you here? Yeah, so this is review. Of course, it's basically a loop, right? A plan, review the plan, make sure that it goes alongside. By the way, here in the review part, it might be, if you're not a technical person, this is when it comes really handy to have a friend or maybe a consultant or whoever, right? Somebody that knows that it's more technical to just kind of review, and you can ask your architect to say, give me a high level of what is it that we're going to do, and let me know if this, give me something back so that I can send this to my friend or whoever is helping me. And that way you can validate stuff pretty quickly, by the way. So just an idea. So this is, okay, so these are some of the issues that I faced once I went to production, by the way. So you might face the same issues. I don't know, let me know if this sounds familiar. So logging, make sure that your AIs are logging everything they're doing. Meaning like logging in the sense of you're adding logs to your applications everywhere, right? Just make sure that that's built into your instructions. Environment flags, whenever you're deploying to different environments, make sure that you flag different milestones or features or whatnot so that you can revert back. That's one of the issues with vibe coding, is that it just moves forward. It's hard to move back. Have you guys figured that out yet? Okay, good. How do you guys do it? How do you guys go back when anyone has come up with a solution for that? Start over? Yeah, no? Yeah. Yeah, but how do you go back with version control if your AI is controlling, is always moving forward? The AI is not going to go back. No? Yeah, so basically, the way that we did, oh yeah, go ahead, please. Yeah.
So my main issue, I think it was very important what you were saying, to always keep track of the prompts and so as soon as you go forward, you can't go back. Yeah. The main issue I've had was possibly like the prototypes. I would have various prototypes, but then I'd always have to restart again completely. And it was like so tedious to the point where I'm just like, okay, you know what? I'm going to try to go slow or, not try to do everything at once, but try to also, check the code, recheck the code over and over again, and then try to fix it, tweak it, instead of just
we're relying on a prompt the entire time. I think that's what helped me. Yeah, and- yeah.
One other thing I would say here is that flags really help you. This was a hard problem to crack for us. How to do versioning control, how to go back when you're doing vibe coding. I mean, we can have a full talk just about that, by the way. But I would say flags really help you. Make sure that you have a good branching strategy, and make sure that everyone knows, or everyone in your team knows this by heart. Like you cannot skip anything when you're doing this with AI, because one person goes off the rails and everything goes off the rails, and then it's a mess. So what else? Error traces. Make sure that, of course, you tell the AI to track everything, and deployment markers, which I think you already use in an enterprise version system. This is something that we already used before, but it's harder to do with vibe coding. All right, great. So these are some of the issues that we also faced. Make sure that what can I tell you? I think we talked about some of these issues before. Yeah, the input inconsistency, that's something that you're gonna face a lot when you're doing vibe coding at an enterprise level. It's like you have to be consistent across different, like if your AI architect brings you some sort of prompt or instructions for different AIs, and the AIs decide to do something on their own, that also was a problem for us, right? So you have to make sure that you standardize templates across different AIs. So the QA AI knows exactly how it's going to receive the instructions from the architect AI. That's what I mean. You have to standardize the communication between them, and then make sure that you put some guards around them. They cannot just go off and execute whatever they want. What else I can say here? Oh yeah, health checks and monitoring is super important when you're working in production level. Make sure that you have a strong monitoring strategy when you're shipping this out. So what is the result? So what we end up putting together is this solution. We call it closed use. I'm not here to pitch you about the solution. I just wanted to show you what we were able to do. I started initially on my own, building this for a month, and then I brought in a few of the people that collaborate with me, some of my team members, to help me bring this to the finish line. What I built, it's not like I built the whole thing on my own, by the way. That's not true. What I did build is a really solid base and a methodology on how to do this faster. And at the same time, it allows us to bring people together, more people, augment the team, and really amplify the impact. If I were to compare how much code or how much time it would have taken me to do what I did in 1 month, just without vibe coding, it would have probably taken me about a year to do that. It's 60,000 lines of code. I code across 3 different types of applications, and many backend services that I had to stand up. I was really surprised on the impact. I was skeptical to begin with. So that's a lot. That's like 20x what anyone can do. Go ahead. What was that? With vibe coding, how long did it take me? 1 month, 4 weeks, more or less. Yeah. And I wasn't even working on the weekends, honestly. But it's not a testimony about me. It's really a testimony about how, when you leverage the systems in an enterprise level way, you can really get a lot of stuff done, and it's production level. So that is really the take on this. So this is yeah. Go ahead. Yeah, of course. Yeah, no problem. Of course. Let me just play you this. This is what we. Oh, does this have volume or not?
Only one way to find out.
Let me see.
Yeah, it does.
Yeah?
Let me handle that with the
Yeah, go ahead. Sorry. It's a 1 minute video. I just wanted to show you what we came up with.
Let's go ahead and play it. And if you could put the microphone here so they can hear it on my screen.
Yeah, sure.
Actually, let me do it like this, actually. Okay.
Yeah.
And then free them from all the admin work so they can focus on selling. You are imagining closing. Imagine cloning your best sales rep and building an all-star team with them. And then free them from all the admin work so they can focus on selling. You are imagining Closius, a powerful AI sales coach and assistant that transforms every rep into a top performer. Closius connects to your CRM, sales docs, and other work apps to understand your deals and you personally as a seller, bringing just the right info about deals and key insights to help the seller prep for a sale in just a few seconds. During your sales calls, Closius becomes a powerful companion, providing real-time tips, insights, and personalized coaching based on the conversation. After the call, head to the Closius web app for the call summary, action items, a full analysis and metrics at both the seller and the deal. That valuable data is used to track seller performance and deliver personalized tips and feedback based on company sales strategy and training. The result? Countless hours saved for both sales leader and seller, better execution across teams, and more wins. Ready to turn every seller into a star? Then join our private preview. Visit Closius.ai, limited spots available.
You guys can hear me? Yeah. Okay, so that was the result. Yeah. By the way, you guys can sign up if you guys want to for a private preview. Cool. I think that's it, right? Is there another? Wait. Is there another slide? No, I think that's it. Yep. So that's it. Any further questions, comment? By the way, 99 out of the 60,000 lines of code, I actually wrote maybe 50 by hand, maybe 50. That's crazy. Yeah. Anyway, any questions, comments? Yeah, go ahead. Yeah, I should have it. It's just not my computer, but I'm happy to share it.
Just for the live stream, I asked if he has a video of the actual end product working.
Yeah, no, I don't have it here because it's a PDF, but I can share it with you. If you guys want, you can go to, actually, there is in the website. There's Closius.ai. There are videos of demos and things like that. So feel free. If you guys want to sign up for a private preview, it's free. No,
Yeah. What we can do too is we can put a bit of a video or something of the product working on the YouTube video when we launch it, when we release it. So there we go. So if you want to stay tuned, when we release a YouTube video, it'll be on there. So there we go.
Cool.
Any questions?
Any questions? Last comments? Yeah. Yeah, I'm trying to go back, but oh, wait. Oh, exit. Sorry. This one?
Yes, I was curious about the first one, environment drift.
Oh, sorry about that. Oh, here, okay.
Yeah, can you talk a little bit more about the environment drift across deployments? The first one in what broke?
Yeah, so environment drifts, it's about one environment, because, okay, so it means a few things actually. So when you set up different environments with AI, you have to think about how you're going to go back in case, let's say you have production, right? And you have to figure, like, because vibe coding really is built to just move forward, not really go back so much or really go back to an issue. Let's imagine that you're in production and then all of a sudden you have a bug. How do you go back to the point where you vibe coded that? And how do you fix that, right? So the way that we set it up to do is that we set up different environments, and each environment has all the context and all the, everything that it needs to just run on its own. But we also set up the same sort of, the same setup that you saw, the architect and all that, we set up its own thing for production. And the reason why we did that is so that we could, in production with AI, find issues very quickly, and then go back and merge back into dev, or do a hot fix, basically, right? So because you need to have some sort of like if you go back to traditional coding, you need to have a hot fix branch out of production, or out of QA at least, right? So, but we noticed that we started to have some environment drift, because the one AI will start to execute in a different way than the other AI of the other environments. So we started having that issue. But then what we decided to do is sort of like have a consistent sort of source of truth for all the configuration, for all the prompts, for everything. We basically have one core, everything for any environment that we use. Yeah, I don't know if that makes sense. Yeah. All right. Any last questions? I think. Well, thank you so much for paying attention. Thank you for the questions. And yeah. Thank you, Grant.
Thank you so much.
Yeah.
Amazing, amazing. As always, thank you so much, Dustin. Let's give it one more round of applause for Dustin. Thank you so much. I know I learned a ton from this session, a lot of new tips and tricks to how to vibe code professionally and so that your architecture is understood by the AI before you even start building it, right? That's one of the key takeaways. I mean, a week and a half, is that right? For planning it before having a go.
It was like a week or so that it was
Right.
just planning. Yeah.
That's amazing. And just for the audience and for everyone watching online, we'll be actually releasing those PDFs and so forth for the audience, and so that you can get your own understanding of how that works, and so that you can improve your own vibe coding experience from one of the pros. So he's, again, a lot of great experience over at Chameleon, working with a lot of great companies and corporations, formerly at Microsoft for multiple years. And so definitely stick around. And if you have any questions, feel free to ask personally. And if you need any solutions helped with, Dustin's more than happy to help, right?
Yeah, of course, of course.
Amazing. Well, thank you again so much, Dustin. We really appreciate it.
Yes, of course. Thank you so much for the invite. I just
Absolutely.
wanna do a quick picture.
Oh, yeah.
We usually do this.
Yeah, let's do it.
We do a quick picture for everyone. Is everyone there? Thank you so much.
Amazing. Amazing. Thank you, everyone, so much. Appreciate it. Thank you, Dustin. Woo! And now to our second speaker. So where is our second speaker? No, I'm kidding. He's parking right now. He's walking over right now, so he's going to be in here in just a moment. He actually had to drive down here from more north than Fort Lauderdale and West Palm Beach, right? So he's pretty high up there. So it took him about a 3-hour drive to come. So we really appreciate Muntazer. He's a really great community member, AI advocate. Actually spoke on the OpenAI Academy. You watched that one, right? Yeah. What did you think of that one? Amazing. Yeah. So many great custom GPT tips and tricks, right? Yeah. That's super cool. So you learned something from that one? Nice. What did you learn from that one? Not to put you on blast, because it's been probably a while back. So, but that's cool.
So testing out a lot of the custom GPT's capabilities, you realize that you have a limit on files that you can reference. And so he walked us through a way to do tool calling and how to actually have Pinecone so that you can host more files and then, really power your custom GPT with more of a deeper, larger knowledge base. So that was amazing to see it live. You followed through. I followed every single step of the way.
Muntazer always delivers, and definitely is going to be a great experience. Who here has been playing around with MCP servers and wanted to learn more, really? Quite a few folks in the audience, so cool. I know maybe some folks haven't learned about it yet, but that's why we're here tonight, right? Learn more about MCP server best practices. It's really changing the game. It increases my development speed so much, and not more than just development speed, but everything, really, because you can connect it to your learning materials, you can connect it to your Canva. It's really incredible what you can do. And here is Muntazer, the man, the myth, the legend himself. Okay, so we'll go ahead and get started in learning more about MCP server best practices. The man, the myth, the legend, Muntazer himself. Let's give it up for Muntazer. We were just talking about your OpenAI Academy session, and she was actually watched it. Yeah, so she was telling us about what she learned from it and everything. So thank you again so much. Yes. So Muntazer is an AI advocate here at Deep Station, and also Gen AI lead for Insight Global. Is that right? Formerly NVIDIA as well, hackathon lead, working on technical insights over there. Very great researcher and developer. A good friend of the Deep Station as well. So thank you again so much, Muntazer, for making this happen. Yeah, so we're going to go ahead and just get you set up here. So just give us a few seconds and we'll go from there. Thank you. I also want to give a quick shout out to the OpenAI Academy. If not everyone knows, we're actually the very first technical workshop on the OpenAI Academy. We helped launch it with the OpenAI Academy. So we're very, very happy about our partner and our partnership, and definitely give them a watch on there anytime. Always have so many goodies. If you're looking at prompts, if you're learning how to use ChatGPT, custom GPTs, definitely give it a watch. We'll be on there again next month. Okay, so we have the terminal. Flash drive. Oh, I see. Oh, what happened? How do I minimize this? Let's do this for now. And for those watching online, we'll be ready in just a second, so stay tuned. Yeah, sure, of course. You need this?
Yes.
Okay, perfect. Window update again. Classic.
It just updates when you don't want it to come.
Right.
Okay, let me just.
Who here, by the way, show of hands, who here is this their first Deep Station event in person? Ooh, quite a few, almost half, around 25%, 30%. Cool, amazing. Who here has been here before? Yeah, yep, amazing. And who here is a business professional? Cool. Who here is a developer, engineer? Cool, all right. Roughly like half and half, I would say. Amazing, amazing.
What's the name of this?
What was that? Is it too fast?
Do you have a notepad or something?
For what?
I want to show this website off, like, so people can go to the GitHub repo. Yeah.
Oh, I see what you mean.
Like a,
I see what you mean. Like Figma Jam.
like a notepad. Like an app that shows you text pad, text editor.
Yeah, I do.
So make a new one. Throw that.
Or do you want to do docs on one?
No, because I want to. Sure.
Yeah. I'll put that in control.
Yeah, that's fine.
very quickly, if you are a developer, then if you're a developer, you know what GitHub is. So all the material I want to present to you today is on GitHub. If you are not a developer, well, welcome to the world of GitHub. GitHub is where developers put their code, and most of the code that's open source in the world is usually found on GitHub. So for this, for today's session, I've made a bunch of materials that's on GitHub. So if you can go to this website, which is github.com/JEMSBHAI/MCP lectures. And we're going to get underway. Okay, so this is basically what you're going to get when you go to this, when you go to the GitHub. And does anyone need that website again? All right, I'll leave it up there for a couple of seconds. And once you do so, we're going to jump straight in. So just to give you a preface, today's talk is a little bit more on the technical side. So this is a kind of useful thing for the AI engineers and developers who have been dabbling into making or integrating generative AI into their workflows, into their daily lives, into their software. And one of the most useful tools that have come out in the last year, I would say, is MCP, or Model Context Protocol. And Model Context Protocol basically transforms generative AI from something like almost like a parlor trick, or something like, oh, wow, that's pretty cool, to, hey, this can do some cool stuff for me. This can make my life easier. This can make my workflow useful. So essentially, it's like giving your AI hands to do things. If you're familiar with the ChatGPT interface, the ChatGPT interface sounds good. It's a language model. So you talk to it, it talks back to you, it seems intelligent. This is the next step. You tell it to do things, and it will do things for you as long as it has the tools. So this is the paradigm shift that came about last year. MCP is less than a year old. But in this 1 year, people have started integrating MCP into all sorts of things. Pretty much every large tech service has an MCP integration. For engineers, if you've been around since the early www days, the .com days, this is to AI what APIs were to the web. So if you remember when, maybe you don't remember, but for those of you who do, when the internet first came out, it was really cool, but there was no easy programmatic way to access things over the net. And then people started writing this thing called APIs. And this is essentially an analog to that. AI came out, or generative AI became popular a couple of years ago. Now there's a way to make it useful, and that's MCP. Okay, so I hope everybody has that, have the website, and let's get started. Okay, I'm gonna walk you through the structure of this. So this is all Python notebooks. Who here is familiar with Python? About half of you. Okay. Python notebooks, I guess the same half. Good, okay. So with Python notebooks, you can actually run them in your own environment. So you can download code from here and run it. I'm not gonna, I have some slides for you guys, but I think it's in the interest of time, it's gonna be more effective for me to just go through the material as is over here. It's very intuitive once you get to see what we have. We have a bunch of stuff. I'm not gonna go into detail. I don't wanna take up half your Friday night or like all of your Friday night. So just bear with me. At the end of the session here, I hope you can come away with an understanding of how MCP can make your AI workflows useful. And for the engineers here, how you can use MCP effectively in an enterprise environment. So instead of just like writing a hello world or like, hey, this is a cool app, what are some of the development challenges that MCP presents, and what are some of the solutions to integrating MCP into your software frameworks? Okay, so let's get started here. Again, this is not a slide deck, and you can actually run stuff here. Okay, so first, what is MCP and how does it apply to agentic usage? If you can see here, this is what we've been used to when generative AI came out. You're a user, you talk to ChatGPT, it gives you a response, right? We're moving away from that into you as a user can create agents. So every chat interface, AI-driven chat interface, has now an agentic interface, which means you can give it tasks, do this, do X, do Y, and the agent can interact with whatever it needs. You've probably seen this in ChatGPT now. ChatGPT can search Google for you. That's a service. It's doing an action. Gemini can make a document for you, do deep research and make a document. So it can interact with APIs, it can interact with files. So in order to do this, agents need to be able to plan, reason, act, and be autonomous apart from you just prompting it and it giving you a response. Okay, so the problem here is this issue called the M times N interoperability problem. So when we have all these abilities, so we have an agent, and the agent is able to connect to databases, can connect to Google search, can look at files. What if I have multiple LLMs that I'm using? How many of you here use more than one LLM? Pretty much everyone, right? So if you do that, what happens? You can see that every LLM wants access to every different service. Your Claude wants Google search, it wants access to your Gmail. ChatGPT wants access to your Gmail, right? So you have this M times N problem where you have multiple accesses which are required by your LLM. MCP at its foundation solves this problem. So instead of having several independent pathways to all these guys, there is one standard that all of the tools connect to, that all of your LLMs can now connect to. So what that means is, let's say we have Slack and you want your ChatGPT to access Slack. So instead of you writing an adapter for ChatGPT to Slack, then you write an adapter for Gemini to Slack. Slack publishes something called an MCP adapter. And this is universal for anyone who wants to apply, or any LLM that wants to connect to this service can use this MCP adapter to connect to it. So remember when we said APIs? APIs provide the same thing. If you want to look at the weather, there is a weather API. If you want to do a search, there's a search API. And it doesn't care who the client is. Same way, the MCP doesn't care who the LLM is. As long as the LLM follows the protocol, it can access that tool. And this is at its heart what MCP provides. Now, if you think about it, this makes the development and proliferation of agentic workflows very easy. It means now I don't need to write a custom way to get some data from my Postgres or another custom way to get data from GitHub. As long as I follow the MCP standard will define, hey, here's how you get data from this source. Here's how your LLM can use data from X source, Y source, etc. So that's essentially what MCP is. Again, there's a lot of text here. I'm not gonna be reading through it because I don't want to waste time. I'm just going to go over what MCP is, how we use it, and how we can better use it in our enterprise. So this is the MCP overlay or the overall architecture. So at its heart is the LLM, it's the AI model, and you have various different clients on the LLM side. They connect to MCP servers, which are attached to the different tools that you have. Again, every large tech product has either an official or unofficial MCP server that has been published. Google Search has an MCP server, GitHub has an MCP server, Snowflake, you name it. Whatever you can think of that's being used in the tech world has a sort of MCP server. And if it doesn't have an MCP server, guess what? You can write your own MCP server. We're not gonna do the, go deep into the hands-on, but the code here allows you to write an MCP server that allows the LLM to access the files on your computer. So one famous thing is when you work with an LLM, usually the LLM cannot access files that you have locally. So sometimes it'll just tell you, hey, do this, do these steps, and you basically are following the MCP or following the LLM. Guess what? With MCP, you can get the LLM to actually do all those steps. You don't have to kind of be like a puppet for the LLM to control. So these are the various components. I'm not gonna, again, go into that much detail. And this is a code definition for the various components of an MCP. Okay, so when we talk about what an MCP can provide and what it can do, there are these basic components that an MCP has that provide your LLM capabilities. So the first is called tools. So tools are specifically things that execute commands or things that allow your LLM to execute commands on a remote resource. Second is resources. If you want to get some data, if you want to read some data from somewhere that the LLM does not have direct access to, that comes under resources. And prompts is guidance or instructions that go directly to the LLM. Remember, the LLM, again, is fundamentally, it's still a language model, which means it follows prompts. So you can program the MCP structure itself to contain prompts that act in accordance with resources and tools. So for example, if you are searching for something on Google, right? You can actually include a prompt that says, don't get me all the results, just get me the first page, because nobody looks at the second page of Google, right? So these are the tools that are the executable functions. And again, I've included code here for the engineers. You can take a look at what the definitions are. Resources, which allow the MCP protocol to provide information to the LLM, and instructions for how to deal with the tools and resources that the MCP provides the LLM with. Okay. So how does MCP communicate? So there are two basic ways that the MCP protocol defines communication of data across this whole framework. The first one is the standard IO or STD IO. This comes from C or C++ if you guys are familiar. And this is limited to the use case where we have the server and the host locally on the same machine. So if you have something that you are accessing that does not require a network connection, MCP protocol basically states that you need to use STDIO. It's simpler and it's more scalable, and then it doesn't have the overhead of going through an entire network stack. However, in real life and in the enterprise settings, this is usually never the case. So this is the standard for the MCP protocol communicating over a network. It uses something called HTTP SSE. So this essentially means that there is a network stack. The communication is essentially HTTP post requests, and it has SSE responses. And the advantage of using this is because it's HTTP, you can do processes like OAuth. You can do processes like opening up JSON LD, and you can have all the bells and whistles that the HTTP protocol provides you can be also utilized by MCP. So here's a quick comparison of what each of these methods provides. And the main advantage here is because it's HTTP, you can have multiple connections, multiplex connections, multiple clients, and it doesn't really affect the implementation. Okay, so how does MCP work? In a nutshell, this is what happens with MCP. For those of you who remember HTTP or networks access diagrams, this is essentially what happens. From the client side, you get like a hello. The server gives you a response with, hi, I'm an MCP server. These are the things I can do. It gives it a notification. The client gives a notification of, this is what I want from you. There's a session where there's a back and forth of information. Usually it's a list of tools, list of resources, and list of actions. And finally, the client closes the connection whenever the task is complete. So this is how MCP works in a nutshell. And then here is some code that allows you to set up a development environment for the rest of our talk. Okay, next. So you can navigate through these. At the bottom, there's a link that goes to the next one, so you don't need to go back into the index. Again, these are the three pillars or three components of MCP. And what is a tool? So remember, the tool is the hand of your MCP. An MCP can have multiple tools. When you design a tool for an MCP, these are some of the good principles to follow for tool design. Single purpose, a tool should have one clear purpose. So if your tool is to send an email or generate a document, it should only do that. You shouldn't have a tool that does 20 different things. If you have 20 different things to do, make 20 tools. Well described. So the description of the tool is important in this case because A, readability by users, and B, readability by the LLM. Strongly typed, which means please follow JSON schema conventions. Deterministic behavior. So when the tool is not supposed to be AI by itself. The tool is supposed to have deterministic outputs. You give it the same input 1,000,000 times, it should give you the same output 1,000,000 times. That's a definition of a good tool. If you had a screwdriver that worked only once every 3 times you turned it, it's a very poor screwdriver. So think of it that way. A tool should always do what you expect it to do. And then graceful failure. This is a good coding practice to have, which means if it fails, you should at least know why it's failing. And this is not just for users, it's for the LLM to be able to understand that there's a tool failure and how to recover from it. Okay. This is some code that defines a tool. So again, you can skip this part if you're not going to do the coding. And here is an example of what happens when a tool is called. So a tool can give you or when you are doing a discovery of what tools the MCP server provides, you can do a request that looks like that. It's tools/list. And then the MCP server gives you back a list of tools like, in this server, I give you 2 tools, calculator tool and flight search tool. And then if you want to execute a tool, you can say, I want to do a call to a tool, and this is the tool I want to execute. I want to do a search for flights, and once this tool is called, here is the response that you get. So if you look at this, it looks very similar to an HTTP request and response. And that's because it's been designed so that the LLM can consume the HTTP-like response. Okay, can you put the timer back? Yeah. All right. Okay, so we looked at tools, and we looked at the best practices for tools. Next is resources. So the resources basically allow the MCP to provide data. So if you want to read some data from a resource or from a server or from some kind of database or data store, this is what you would use. Now, not all MCP products or MCP servers support everything. Some MCP servers, for example, don't support tools. They only support resources, which means you can only read stuff from the server. You cannot get it to do anything. That's fine. The protocol allows you to do a lot of things. Individual servers might have different capabilities that it exposes or doesn't expose. So in order to get resources, this is the formatting that you use for resources. So you can have resource parameterized URLs, and you can provide specific methods for resources. So you can do resources list, and this will give you, or this will get the MCP server to respond with, here's all the resources I have. And then you can get the templates, and you can fetch an individual resource. As you see, this is a specific weather resource, a forecast for a certain day. You can also set up resources to be subscribable. Who here is familiar with the pub-sub model, not public subs? Okay, so outside of food, the pub-sub model basically is a publish-subscribe model, which means instead of setting up a connection, you can subscribe to a certain resource or a certain data source, and you get notified every time something is published to this data source. So for example, when you have a newspaper subscription, you don't query the newspaper office every time. You have a subscription. They have a cadence at which they publish the newspaper. Every time they publish it, if you have a subscription, you get it. The same idea applies to resources and data over the internet, and essentially over a lot of different sources of data. And here is how we can get the MCP to perform a subscription workflow with resources. And next, the third pillar is prompts. So the prompts so the resources and tools are probably something you've already seen if you're familiar with API programming, but prompts is a newer aspect. Because here, this essentially tells the LLM what to do with the data it gets or how to invoke the data. So for example, you can put in a prompt for performing some action. So for example, if there's a prompt that says plan vacation, you can actually encode this entire prompt as MCP recoverable service. So here is here's a pre-written prompt for planning a vacation. And why would you want to do this? Code review, meeting summary. So if you think about it, when we use AI to do if we want to use AI to do useful tasks, one of the most useful tasks we can do is automate the repetitive stuff that you do, right? So in your work role, if you have a task that involves opening a file, looking for something, copying it out, throwing it in another place. So if you think about it, that's like 4 or 5 different steps. And if you want to automate this, you want the LLM to understand that here's a task, here are the different steps, here's what you need to do, and here's your workflow. The prompts part of MCP allows you to encode this information as various steps and store them. So if you think about it, it's almost like macros in Excel. If you're familiar with macros, how many of you guys know what macros are? Most of you. So in macros in Excel, this is what you do. You have certain steps, you encode those steps, and then you click the button and the macro runs, right? It's the same concept, but with AI. If you want to teach the AI to do complex tasks, you break them down, you encode them as a prompt, the MCP server knows, hey, this is a prompt that people use, and then essentially do that same task. Why do we use it with MCP? Interoperability. So if the prompt is a resource on the MCP server, it's not just you. Anyone who wants to follow these steps can just invoke the prompt and do it. So if it's, in this example, we're planning a vacation, and not just like it's something that other people might do. So I'm going to do a vacation. This is all I need. Somebody else will do it. They need kind of the same way, and these are the same steps that they follow. Okay. And again, prompt methods are given over here, discovering what prompts are available, how to invoke a prompt, and getting a response for a prompt. This example is for a flight scheduler or a vacation planner. You can write your own. And then I've also included here some design patterns for good prompt usage. You can use this for your own prompt writing. Okay, so what happens in MCP? Who controls what? The user can specifically control the prompts. The application can decide where the context is going to be with what resources, and the model can decide which tools to use to perform this task. Okay, and here is a complete MCP server example. Again, if you are a programmer, you can use this as a template to write your own MCP server. And this is essentially what happens with this MCP server in terms of a workflow. So the user just goes to the LLM, I want to plan a vacation. The LLM knows that it needs to fulfill these parameters. So it asks the user, where do you want to go? What are your dates? Once it has everything to fulfill the prompt, then it goes to get the calendar, the travel itinerary, and also what are the preferences of the user. Once all the information is available in the context, then the model can call the tool based on everything that's available. Once the tool is invoked, the user gets the results. Here's a vacation I planned. Do you want to book it? And so on and so forth. So if you think about it, whatever work you do, whatever action you're taking, can be encoded into various steps where you need some resources, some information to fulfill your request. You need some actions, or you need the LLM to do certain actions. Those are the tools. And you need a prompt, which is basically the orchestration of here's what happens in what order. And finally, this is how you get the AI to do work for you. Okay, so that's basically how the MCP works in a nutshell. Let's take a look at transport mechanisms. I'm not going to spend too much time on this. In fact, I'm going to just skip the standard I/O transport because this is a little bit in the weeds. And then you can look at the security stuff. Let's go to HTTP SSE. Okay, I'm going to talk a little bit about the HTTP SSE because this is network transport, and here's where this is basically something that if you are building MCP servers, you're going to be using a bunch. So we're going to look at why we are using the combination of HTTP SSE. SSE, by the way, stands for server-side events or server-sent events, and how to make up a connection, and how to move data across this connection, and how to secure it, and how to kind of tear down the connection once everything is done. So these are the advantages of HTTP SSE. In the enterprise, these are very, very important things. So you need to be able to load balance, scale, deploy on a cloud. You need to be able to authenticate using a well-known or well-regarded authentication method. This uses OAuth 2.1 because it uses HTTP, so we are allowed to use OAuth 2.1. The authentication schema uses tokens, and you can control the level of access. You can do role-based access. You can do query-based access. So these are all things which are very, very important in the enterprise level. On a higher scale, this allows concurrent connections. It allows M2N, so multiple users, multiple resources type schemas, and you can scale horizontally. So STDIO is only for the same machine, one user. With HTTP SSE, you can have a server serving multiple clients simultaneously without, as long as there's enough resources to go around. The load balancing is also supported by this protocol. Okay. So everybody knows what HTTP is, I guess, by now. Hypertext Transport Protocol. Server-sent events essentially is a way for servers to send clients things that happen. So if you think about it this way, it's in the name. So if there's an event, the server sends the event to the clients. And here is the format of what the messaging is when there is an event that's sent. And this is a example of the structure. So when we have an HTTP and SSE, this is how the connection goes. So if you think about it, you might be familiar with the GET and the POST requests. The SSE request is what's new. So the SSE goes from the server to the client. So when you do a GET, which are the request types to the server sends the responses are the server sent events. And the entire workflow that we looked at earlier basically follows this same protocol. So the MCP server requests some resources, some tools, and something happens on the server, and it gets encoded into a server sent event and back to the client. Okay, I've provided some code that allows you to use HTTP SSE to create your own server. So there's a library called FastMCP, and you can use that to quickly spin up an MCP server. You can do it without FastMCP also, but this goes a little bit deep into the protocol itself. With FastMCP, essentially it encodes all the communications under the hood. Okay. Well, here are some best practices if you're coding. This is something that you should follow. Use unique IDs, validate sessions, clean up the resources, and you should handle reconnections with some well-known things like exponential backoff, etc. Okay. One more thing I want to cover in this slide before we move forward is the authentication. So this is very important. a lot of times when you are connecting to an MCP server, say you're connecting to the Google MCP server or the Gmail MCP server, you need to authenticate because you need access to your emails. You don't want to access, or the server doesn't want to give you access to everybody else's emails. So in MCP, HTTP SSE follows the OAuth 2.1 workflow. OAuth 2.1 essentially works like this is the OAuth 2.1 flow. Without going into too many details, it's essentially the user authenticates, gets a token, and the token basically has parameters like how often can it be refreshed, what it's tied to. It's tied to a session, it's tied to a user, it's tied to a machine. And oftentimes there is an encryption at rest and encryption in transit involved here. And because it's OAuth 2.1, you have both an access token that allows the actual data to be accessed, and you have a refresh token, which means the access tokens always have an expiry time, and once it expires, you need to use the refresh token to get a new token. So in short, this is how OAuth 2.1 works. And OAuth 2.1 is not an MCP-defined protocol. It's a well-known standard. And MCP adopts OAuth 2.1. So if you have your network infrastructure and your security protocols compliant with OAuth 2.1, or if OAuth 2.1 meets the standards for your security, you are good to implement MCP with HTTP SSE. Remember, the other way of transport, the STDIO, does not support this kind of authentication, so you need to be careful on that regard. Okay, here's a code for a client-side implementation for HTTP SSE, and this is the strategy for reconnections when you have long sessions or you want to reconnect to the same session of an MCP server. Okay, finally, here's again the comparison of STDIO and HTTP SSE. Again, the notebooks here are very comprehensive. So if you go through all the exercises, you're gonna get a very good understanding of how this stuff works under the hood. Next, let's actually not do this. So if you guys want to, you can go to Notebook 5 and start coding. And this basically takes you straight into FastMCP. FastMCP is a library that you can use to develop your own MCP servers. We start off with like a hello world, and this kind of shows you how to create tools, how to create resources, etc. Things like normal sequential query tools, async tools, and tools that augment the context of your LLM. You can also create resources, prompts, and this is the end-to-end example. You can create an MCP server that takes notes for you. So if you have time, I think we're gonna be here till midnight. So if you wanna stay back, I can walk you through all this code once we are done with the main materials. Okay, and then there's some testing environment as well. MCP, all right, let me just make this clear. MCP was invented by Anthropic, the company behind Claude. So a lot of what you see works with Claude is MCP centric. So Claude Desktop, for example, has a lot of capabilities that are essentially a bunch of MCP servers that are working to do your commands, your actions. I'm not sure if you guys have access to it yet, but there's something that's been released. It's gonna come out in like public release very soon. It's called Claude Cowork. So it basically allows Claude to do work for you. And I'm sure OpenAI and Gemini and Perplexity and the others will soon follow with their own versions. But in terms of MCP itself, this has been a major breakthrough in terms of AI capabilities, and Anthropic came out with it, so Claude has this capability. Okay, let's move on to Okay, so like I said, there was code here, like I told you earlier, that allows your LLM to control your files or gives you file access. So if you want to take away one useful piece of code from this workshop or from this talk would be this guy, which is the file system MCP server. So this is basically a step-by-step walkthrough of how you would create an MCP framework, an MCP server, and connect to an MCP client that allows your LLM to work with the file system you have. So if you have files that you're storing locally, Excel files, PowerPoint files, whatever, and you have tasks that you need to do with them on a regular basis, if you follow these steps, you're going to be able to implement this at a granular level. Okay, so instead of going through code, so this is something called MCP Inspector. MCP Inspector essentially allows you to test the capabilities of an MCP server without live running it. So if you're in the process of developing your MCP server, it's always a good idea to test. As you know, with software development, testing is very important. And MCP Inspector is one of the test tools for MCP servers. Okay. All right, let's go into the best practices for MCP servers. First of all, security. I like to use the mantra that security is not something you do at the end. Security should be something you're thinking of from the beginning. Because if you do security at the end, you are just applying a lock to a door where you have 50 windows, you have a roof, and you have all sorts of access methods. We've all seen Mission Impossible. So if your door is locked, he never goes in through the door. He always goes in through like a vent or something like that. So you got to think about these things when you are thinking about security. Let's do that. Okay. So for MCP security, the first thing is principle of least privilege. So you only grant the minimum of what's needed. When you don't need write access, don't give write access. If you have a resource that that should not be editable, don't make it editable. Give it only read access. Limit the scope of the API. Oftentimes it's very tempting to say, oh, just grant access to everything and we'll figure it out later. Very bad idea. Defense in depth, so have multiple layers. Make sure everything is valid. So this is not just for security, it's for any kind of interface. So remember, when we use LLMs, you are using tokens. And at an enterprise level, tokens are not free. So if you have a misformed URL, if you have misformed data, you are definitely going to burn up tokens generating errors. So it's gonna be wasteful. So in order to cut this waste, it's a good idea to have validation before you go into a production workflow. And then log everything. It's a very good idea to have audit trails, not just for security reasons, not just for bookkeeping reasons, but also for the fact that when you are upgrading things, when you are improving the quality of your LLMs or the quality of your tooling, this is the first place you can look to see where your improvements will affect. Okay, so next, let's see what our validation process is. So here's an example of some validation patterns. This is classic SQL query validation. You can use validators in tools. So when you're calling a tool, you have to make sure the parameters the tool receives are in valid format. They don't exceed certain sizes. They have the right kind of data. And that is, that's why you should use validation for tools. For error handling, we have a pyramid-like approach. And this is some example code for MCP errors. So here is an architecture for an MCP server project. So usually, when you design an MCP server, you should segregate your tools, resources, prompts. You should have a separate module for security. And then all the utilities that are commonly shared between them should have its own subfolder. And again, here's an example. So the code here is pretty comprehensive in terms of examples. You should be cognizant of rate limiting and resource protection. So LLMs are very, very hungry when it comes to consuming tokens. And it could be very costly when you're working at an enterprise and there are thousands of users using an LLM. The token costs can become astronomical. So it's a good idea to implement things like rate limiting from time to time. And then we should also have a testing workflow for MCPs when we implement them. So this is a summary of the best practices that we went through. Again, there's comprehensive code that are examples for all of these in this notebook. And if there's something you want to take away, just make sure this is what you take away from here: security first, error handling, logging, testing, and rate limiting. Are we out of town? Yes. Sure. Logging.
Hi, my name's Joe, by the way. So within the enterprise, have you given any thought to like logging the reasoning behind the tool calls? If there is an error?
Yes.
Yeah.
So
Can you talk about that?
very good question. So when we say logging, we're not just logging what the tool gives you.
Yeah.
We can also log the context. So the purpose of MCP is to augment the context that the LLM has at any point to the level where it can perform certain tasks or it can invoke certain tools. When we log, it's not enough just to log what the tool gives you, but if you log the entire context at a certain time, especially when you have errors, you can do a context log, and this will allow you to A, troubleshoot errors, and B, make it more efficient. You don't need to log the entire context. Sometimes you do. Sometimes you need it to be secure. So for example, if you are dealing with a high security environment, so where the access to data is very restricted, you do want to log the context, because if there is some unauthorized access, you need the capability to trace where it happened and why it happened. So in those cases, yes, you can do a verbose context logging. But in general, context logging is important if you want to debug after errors. I'll give you a real life example. There's one use case where I work with a very high security database, and their thing is log everything and make sure it's encrypted. So yeah, we log the context. It's like storage is cheap, but it depends on your use case. But I would definitely be an advocate for logging the context as well. I hope that answers the question.
Yeah, thank you.
Yeah. Okay. All right. Let me see. I have 13 slide decks, but I'm not going to go through all of them. So there's agentic workflow patterns. If you're a developer, this will be, and you're building agentic systems, this is something that you would definitely benefit from, especially because we talk here about the integration of the LLM router. So the router pattern basically knows where to route your requests to. So these various patterns are some of the most fundamental things that agentic AI development. So we can probably have another complete session on all this stuff. But just to give you an idea of what this slide has, it's patterns that are useful to you when you are building agentic AI systems at scale. Ultimately, there's a very, very, I think it's one of the most useful patterns. It's called the evaluator optimizer pattern. And this basically allows your LLM system to generate something and then evaluate, like kind of neutrally evaluate what it generated and then optimize. And this is basically a loop until it gets to a place where it's satisfactory enough to a certain level. And to a degree, this is actually what happens in models where you turn on the extended thinking. There's a version of this that happens in the background. But you can have this done with various LLMs, and you can do this as part of an agentic flow. And if you take a look at the structure of the GitHub repo, I made this guy into its own separate module. So there's a separate folder that has the evaluator optimizer pattern that you can do by yourself. Okay. Again, this is something that is this notebook basically contains all the use cases or all the patterns that are useful for agentic AI development. If you're building agents, I would recommend you to look at this resource. Yes, you had a question?
Yeah, you mentioned this web patterns and module. There's a lot of terminology that you use that is networking based. You know, is there internal ports you call inside to execute this? I mean, does somebody orchestrate pinging a port to get a service and receiving it back internally? Is that something that happens?
Very good question, because I'm going to go to that in my next slide. So that's actually a very good question, because it leads to what I'm going to be explaining next, which is the MCP gateway. This is another network. Okay. Right. So yeah, I'm going to make this the last one, but there's more. We're going to have another session, hopefully, and we'll cover more stuff in detail. Okay, so far we've seen MCP server, clients, and sometimes you have multiple tools, multiple workflows. If you think about it, what we talked about at scale will look like that, which is the client needs to access so many servers, and a server might need to access more servers, etc. So this does not scale very well. It'll turn into spaghetti very, very quickly. So at the enterprise or the large scale level, this is what MCP looks like at scale. So when you look at large companies which deploy MCP as part of their AI solution, they're always behind something called an MCP gateway. So the MCP gateway does all the things you expect a network gateway to do when you are accessing services that are supposed to be deployed at scale. Things like routing, load balancing, logging, rate limiting, automated configuration. So instead of having each server do all these for each client separately, you can have a gateway that allows the servers to be load balanced. So if you think about it, Google has multiple servers across the world. So it's obvious that it doesn't have one MCP server. Google has like hundreds, thousands of MCP servers. How do you load balance between them? How is your request routed? That is done via something called the MCP gateway. So the network, the point-to-point connections between the client and the server is determined by an MCP gateway. MCP gateways, again, allow all these types of advantages, which means your authentication is simplified. It only happens at one point. The load balancing, rate limiting, etc. All the patterns we talked about can be implemented easily if you implement it at the gateway level. And that frees up your server to just focus on the task. And here is the architecture of a gateway. So you can build a simple proxy gateway. You can have an aggregator gateway that connects to multiple MCP servers. You can have a gateway that applies certain policies to all requests. And this is the code that allows you to spin up your MCP gateway. The previous code we saw had MCP clients and servers. You can build an MCP gateway and drop into your architecture. Yes?
Could you co-locate or have more than one gateway? Could you have more than one gateway together in some kind of subnet for regional protection
You
or
can
something?
have hierarchical gateways, yes.
Or for geographical?
Yeah,
Yeah.
of course. Because, again, you can containerize this solution and deploy it via something like Kubernetes. And that would also mesh well with the overall flow and overall architecture. And here's instructions on how to build a gateway. And this is how we do routing, the request routing within gateways. We can do tool calls. And if you think about it, if you have a gateway, it makes it easier on the client side, not just to keep a list of all the servers that have certain tools. It can just say, I need this tool, and then the gateway can respond with, this server has that particular tool, or here's the tools that you need. So in this case, the context becomes more efficient. Okay, and then you can do access control at the gateway level, so role-based access control, and you can have the gateway itself act as an MCP server. And then finally, these are the things that the gateway can do. And we have code here that does all this, all these various things. Again, there's quite a few notebooks more, but those are in detail. I'm not going to go into that, but I'll take questions.
Security layer between the client and the server, so the input and output going back and forth within the gateway.
Sorry?
Like a security layer?
Yeah.
Yeah, within the gateway.
Okay. So the security of the gateway, so essentially, if you take a look at the gateway has its own centralized authentication process. So the gateway can act as an authentication authority, and the gateway can perform RBAC, which is role-based authentication. So when you have certain tools or certain resources that an MCP server can provide, the gateway can either block or allow access to it based on the role that the token simplifies. Yeah, you can have the auditing or the logging on the gateway itself. So you can have the gateway basically write to a log instead of the MCP server writing to a log. So yeah, that's definitely doable. Sorry? So security, so there's nothing that's 100% secure, right? But having security at the gateway level, so it's, when I say we can have security at the gateway level, that doesn't mean I'm gonna not have security at the MCP server level. I'm just adding an extra layer of security. And the first thing is, if you have strong security at the gateway, that's your first line of defense. Because if you're opening it up to connections, then you want your gate to be the strongest, and your gateway should have the strongest line of security. Okay.
And
Yes.
is it open, the security, is it open, like, does it have Kerberos or can you configure something like they're defining new hashes for quantum computing security. So let's suppose that we have to get there in a year or so or 2 years. Could we implement some specific protocol for security?
Yeah, because
Cross-platform, because, there's so many models that I can see that we're gonna have a system that will access many different models and many different systems, so across different clouds, so we may have to adopt some very strong security to do that.
And this will be the last question, except for one more from the live stream.
Okay. So yes, you can definitely use a multimodal security model. Remember, the communication is done via HTTP SSE, and this follows this supports all the security infrastructure that the HTTP protocol provides.
Great.
Okay, let's
And now
get
we're
a-
just going to ask one question from the live stream.
Sure.
I think it might be one of your friends. I'm not sure, but or
okay.
someone. We'll find out. But it's a great question. And
What is
let's go ahead and find that out.
Might be one of my friends. Good.
Potentially. So let's go ahead and open the comments right here. One of our live stream friends. The question is, can you add more info about latent space prompts and accept text prompts?
What is the question?
Can you add more info about latent space? You were talking a while back about prompts. Yeah.
So yes, that's actually a very good question about prompts which are not just text. So when you add a prompt, the prompt is not a static thing. You can have the prompt refer to a resource, and the resource does not need to be text. However, there's a caveat. The LLM, if it needs to understand something multimodal, there must be a vectoring for it. As long as you can embed the input or you can represent the input as some kind of vector, you can add it to the prompt. So what we are doing, the Model Context Protocol, MCP, the second word is very important here with regards to the how. So what we're doing is we are augmenting the context that the LLM has. The way you augment the context is you add in text or you add in a vector representation of whatever you're giving the you're giving the model, essentially.
Amazing. Well, thank you so much for answering that question. That concludes a wonderful session. Let's get a selfie real quick before you go. Let's give it up for Muntazer for on MCP servers. Amazing, amazing. Yeah.
Thank you very much. And please feel free to use all the resources on that GitHub. I will be updating things on there. There are some exercises. I didn't publish the solutions, obviously, but I'm going to provide a solutions folder for it too.
Yeah, and who here, just out of curiosity, who here would like a class on MCP servers, like exercises, go through it, learn it together, build it together, right? Yeah, okay, maybe we make that happen, in the next one of these next months. Yeah. Yeah, we'll be putting together, then based on all the hands up, we'll be putting together a wonderful exercise class for all of you. If any of you want to hop on, it'll be like a multi-hour workshop, get our hands dirty, actually build out an MCP server together. It sounds fun. Amazing. Oh, Rob? Yeah.
Suggestions for classes I don't think anyone here knows Tosser is a legend in the embedded systems, hackathon community. He's won so many, state of Florida and World Series. So basically, he's probably the best expert in the state of Florida for programming real-time systems and embedded systems. And I was thinking, literally, when you drop
Okay, it's very interesting that you brought it up because one of the projects I'm working on in my own time is actually building it. No, I sleep like 3 hours a day. Melbourne. Um, yeah, well, you're welcome. So, thank you. So, one of the things that I'm actually working on, this is like personal to me, is I talked about MCP for your Excel files and everything. One of the things I'm currently working on is building an MCP to control robots. So, giving LLM actual hands. So yes, it's interesting that you brought it up. Hopefully, in the very near future, when I have made a stable release of it, I can do a class based on that library that I publish. Okay.
Amazing.
It's in my car.
We need to see this. We need to see this sometime.
Okay.
Next time. Next time.
Next time. All right. Okay. Yes.
I wonder if you or somebody in the audience can help. What I'm looking for are, we're building a new structure, a new economy based on collective intelligence from AI. So what we standardize is on extending MCP to a front-end UI.
Okay.
Where that UI tells a story in a
Okay.
standardized way. And what I'm looking for are individuals who are both interested in standardizing the knowledge graph, the data graph that's behind the data structures that
Okay.
actually tell the protocol and stories. And then, you know, if there's somebody who's interested in helping establish this new economy, I'd be interested in chatting with them.
Yeah, the community here is very, very vibrant, very active. Grant is heading Deep Station, which is, I think there's like, what, 4,000, 5,000?
4,000 or so. 4,000, more than 4,000. That's just
4,000
here in
people here.
South
So,
Florida.
if you want to join the Discord or the WhatsApp, and you can really get your voice amplified there.
100%. If anyone wants to join us too, we have the QR code right here at
There you
your
go.
convenience. And yeah, one last question, and then we'll go ahead and.
We just had the hackathon, talk about what we did, talk about NOVA, because it's not just only here, they have.
Right. Yeah, very good point. Thank you. So, in fact, we just recently had a Lovable Hackathon, and so thank you so much for all of you for coming. It was really, really fun. And very soon we're going to have more hackathons. You know, these are going to be very, very large ones too, with some of the biggest players into space, and we're going to be doing more of these this year. So stay tuned. We'll be inviting on Luma, et cetera. You know, just think of all the big tech companies. We'll be working to do hackathons with many of them. So stay tuned. It's going to be a lot of fun. And I just want to give a special shout out and thanks to the two great speakers today, Dustin, Muntazer. Thank both of you for coming today and sharing your knowledge with the community. Let's give a round of applause one more time for amazing, amazing. Yeah, and you know, what is community all about, right? It's about getting to know each other, it's about connecting, it's about learning from each other, it's about building together, and it's about making friendships along the way, right? I feel like in some ways AI has taught us more how to be human, you know, taught us more about humanity than anything else, which is ironic. And yeah, so I'm looking forward to talking with all of you, getting to know you. And yeah, moving forward, just for tonight, in Luma it says something about co-working, right? So feel free if you want to have your laptops out, working on something, want to ask some questions with people, feel free. Or if you just want to get to know each other, just talk, you're more than welcome to do so too. So we have locations here in Miami, we have the AI Center and the lab as well. And our next one's going to be in February. We're going to be at the AI Center on February 10th, I believe. And then we're going to be talking about Claude Code and Claude Cowork. So stay tuned for that one. It'll be a lot of fun. You'll learn how to do that. It might be hands-on. And then end of February, we're going to have one at Nova Southeastern University. And that one, we're going to be having our guests from Meta and UKG talking about how to do design with AI, right? How to do design and UX with AI. And so that'll be hands-on, interactive, and also very fun. So stay tuned and see you next time.
All right. Thank you, everyone, for coming.
Amazing. Thank you.
Thank you. Appreciate it.
question for you, which may be an easy answer or may not. At our company, we're building like an app, let's say, just like a web browser. It's like we're calling it